algebraic, and we were taking the minimal polynomial that has it as a root. That polynomial, of course, needs integer coefficients.
In the literature for like 100 or 150 years ago. What's new?
The techniques I've shown are all from 1850 or 1800s, which I've said, but Roth's theorem is actually a much more recent development. It's actually popped up in 1960. This was used to prove,
like 75 years ago, 65 years ago.
Well, it was used to prove that zeta 3 was irrational all the way in 1979. And it was also used, I believe, to prove that any one of zeta 5, zeta 7, zeta 9, or zeta 11 was irrational.
Numbers that are computable and not computable. So for the computable numbers, you know the digits. Some point you can do the approximation. So what if the numbers are not computable?
Well, I don't think that's handled very well by number theory. Assume that we already know perfectly what the number actually is. If there's a question to if the number can
be... Then what's the point of approximation? We practically know.
Well, because sometimes numbers, like irrational numbers, we only know them up to a certain point. For example, like pi, we only know finitely many digits when there are infinitely many digits, or e, we also know only finitely many digits. Or other times, even though we know all of the digits, it's just more convenient to write them as a rational number, because irrational numbers are very tricky to work with.
So what? Like we can truncate the irrational number at some point.
Well, yes, that's the technique that we showed at the start. But unfortunately, as we showed, it's also a very bad approximation technique when you compare it to the most optimal ones. It only approximates at about a rate of 1 over q, as we showed for pi, whereas for, the optimal approximation method for the square root of 2, for example, approximates at a rate of 1 over q squared. Oh, sorry. Just one more question.
So a recent breakthrough in 2011. So there was some Riemann zeta function for particular values. The irrationality measure was computed.
Yeah, that's the only method we found so far to actually find zeta 3's transcendentality. So that's probably the method we'll use to break it.
Was not counted. Irrationality measure was not counted for zeta 3.
No, we don't know it yet.
We don't know.
We know.
We know.
Well, we know it's it. Well, no, we know zeta 3 is irrational, but we don't know its irrationality measure. So all we know is that it's at least 2.
Oh, you know only?
Well, all we know is that it's at least 2, which is the case for every irrational.
Please, I think you can write to him by email. Number theory is very stimulating and inspiring thing. So now you have to get back to Calcutta.